Thank you for joining me today. I'm going to be speaking to you about how to create and analyze dot plots, which are also called line plots. All right, so let's take a look at an example here. This example is just data that represents the number of texts that 20 random students made over a 24-hour period. Each value that you see here lined up represents how many texts that they did in that period. So what you're going to be looking at here is using a number line. You can see there's a number line at the bottom, and you're going to use that number line to collect the data and organize it based on like numbers. So for instance, we're going to go down, when we see a number, go down our list here. I'm going to mark off 12, and what I'm going to do is place a dot above 12, okay? And eventually you're going to do that for every number all the way down the line, and you're going to see that you're able to look at your data and see if there's any discrepancies or anything that stands out. All right, so the next one will be 10. And when you do this, just try to make sure each level stays approximately the same. So the first dot and then the second dot and the third dot pretty much have the same distance. That just helps at the end when you're analyzing it. Then 12, again, 10, 15, 12 again, 10, 15, 18, 25, 12, 15, 9, 8, 10, 12, 10 again, 20, 18, and shocker, another 12. There we go. All right, so now when you look at, and you're basically going to be asked some questions typically, but we just wanted to draw one out so that you see what it looks like. And you can see that there's some collection near the 8 through about 15 range, and then it kind of trails off. Some of the questions that may arise are, where's the mean, where's the median, where's the mode, what's the range? You may even be asked if there's an outlier. If you're asked what an outlier is, 25 would be a very good representation of an outlier, because you can see that it's way away. Then the word outlier probably makes you think of something that just is different from the rest, and that's exactly what it is. It's a number that doesn't seem to fit with the rest of the data. If 25 wasn't there, you probably could even say that 20 was an outlier as well. But in this case, 25 would definitely be your outlier of this data set. So let's take a look at another one then. And this time you can see some questions are asked along with it. We're going to go through and do the exact same thing. All right, so we're going to start with 9. All right, 9 again. 8. All right, 4. 12. You can see just placing dots, and sometimes people will use little shapes or maybe even X's to do this. I guess that just depends on how creative you are. You're just trying to mark the numbers as you go. How you mark them is really not a big deal. You just want to be able to see some type of relationship possibly at the end. So we're just continuing to mark our numbers. Looks like there's lots of 9s, as you can see. 22, 10, 8, and another 9. There we go. All right, so we see we have our data here, and we can kind of analyze what we have. The first question here is asking, are there any patterns in the data? So again, as you look at this, what we'd really like you to see as a teacher is that all of the data points, for the most part, the majority of the data points range from 8 to about 12. There is a 4 and there is a 22, but the closest related points are from 8 to 12. So when we're looking at how many cookies were sold by 15 Girl Scouts, pretty much if a Girl Scout walks up, we can assume, almost make an assumption that she probably sold anywhere from 8 boxes or 8 cookies, boxes of cookies to maybe around 12. Okay. Also, are there outliers? That may be a question that's asked. 4 could be an outlier, but 22 would definitely be your outlier in this one because it looks like one Girl Scout went above and beyond and sold 22 boxes. So if there was a competition, she would definitely win. But the majority of them are right there in the middle or around the 8 to 12 range. Another question or other questions that are asked are what are the mean, median, and mode? So if you're familiar with how to find the mean, we would go ahead and go through the process of doing that. If you're not familiar with the mean, I'll take you through it, but there's another video you can watch on that as well. I'm just going to quickly show you how you can easily put some values together to find the mean. So you're not sitting there adding 9, 9, 9, and 9. And what we're going to use is multiplication. We have multiple 9s here, okay? We actually have 7 of them, okay? I believe 1, 2, 3, 4, 5, 6, yeah, 7 of them. So basically we can use multiplication to help us count these up. So 7 times 9 is 63. So off to the side here, I'm going to add up these values that way. We also had multiple 8s, and you can use your line plot to see that. Notice how I had 3 8s down at the bottom. 8 times 3 is going to give you 24. All right, you can also see that we had multiple 10s. We had 2 10s, and you can see that on the dot plot as well. So that's going to be 10 times 2, which is 20. Then we had 112, 122, and 14. So we've already kind of organized our data and make it easier to add in a way, but you have to use multiplication to do that. So 3 plus 4 is 7, plus 2 is 9, plus 2 more is 11, plus 4 is 15. Carry the 1. 1 plus 6 is 7, plus 2 is 9, plus 2 again is 11, 12, 13, and 14. It rounds up to 145. All right, so when you find your sum there, you need to divide by the total number of values. So that's 145 that we're going to divide. They tell us the total number of values in the actual problem, so we don't have to count them up. There's 15 of them. So 15 into 145. All right, and that's going to go, let's see, 9 times. 15 goes in, times 9 is 135. Right, and again, if you're not sure about that, off to the side, you may have to do some scratch work, times 8, times 7, to where you figure out approximately where it's at. You're going to have 10 left over. So we can go ahead and bring 1 0 down to go out at least one decimal place, the tenths place. 15 goes into 100. That's going to be 6 times. So our mean for this data is going to be right about 9.6, and we should expect it to have 9 in it because of all the 9s that are there. But the outlier is going to pull your mean up a bit, okay? And that's something that's asked quite often is what are the effects of outliers? Outliers can draw your mean up, and they can also pull your mean down. Okay. The next question is what is the median? Well, again, you can use your dot plot for this. Or you can rearrange your numbers. If you've already arranged them on the dot plot, you might as well use those. We have 15 dots, so the median is going to be the middle number of 15, which in this case is going to be basically the 7th, 8th dot. All right, so we're going to start from 4 and count. 1, 2, 3, 4, 5, 6, 7, 8. And if we hit 7 and 8, as you can see, I hit 7 and 8 because my points went away. I'll put them back there. That's your median. We're within the 9 range, and again, you almost would expect it anyway because there's so many 9s if you listed them from least to greatest that you're eventually going to hit the middle number and it's going to be 9. So you'll notice if I count from 22 and do the same thing, 1, 2, 3, 4, 5, 6, 7, that bang, I hit 9 again. So ultimately your median is 9. And then finally mode. This is the easy one. It's the highest group of points. So that's also going to be 9. Now range. Range is going to show your variability, okay? So even though most of our numbers seem to be clustered in the 8 to 12 range, because of 22, the outlier, and 4, the outlier, we actually have some variation here, or variability is what they'll call it. So to find range, again, if you're not familiar, I'll point it out to you. It's going to be taking your largest value, which is 22, and subtracting your lowest value. So we're going to do 22 minus 4. All right, and when we do that, we get 18. So the range in this case is going to be 18. So that's how you can find some information from a dot plot. All right, the last one here. This time the dot plot's been created for you. However, they're asking some questions within the problem. So it says the following dot plot represents the number of times 20 baseball players got on base in their past 3 games. How many total times did the players reach base? What is the median of the data? So ultimately, we're going to go through one by one and answer these questions. So the first one is, how many total times did the players reach base? Well, again, total times means dots. So when I see a dot over 0, that means that was a time a player didn't reach base. That was another time a player didn't reach base. Okay? So out of the 20 players, there were some that didn't even reach base. So in this case, it says how many total times did the players reach base? We need to ignore 0 because 0 isn't going to play a part here. So we need to count all the dots that range from 1 to 6. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17, okay? In this case, we're able to reach base. What is the median of the data? And again, we had to do that last time where we actually had to figure out how many total number, and we know this time is 20, and we're trying to find the middle number. Well, the middle number is going to range 9, 10, 11. So you can start with 0 and start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right there, we're on 2. And again, I'm just counting 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And because we're right in that range, we've actually already passed the halfway point. If we're at 11, we know that our median has to fall at 2. Now just keep in mind though, you can always list these out in alphabetical order starting with 0, and you can actually list them by number instead of dots, and you can find the median that way as well. It's already done here for you, but if you're more comfortable doing that, you can do that. All right. What is the mean? Okay, well, we're going to actually go and find the mean by determining the total number of bases. So in this case, we have 3 players who got 0. So we have, basically, we could list out the zeros if we need to, but we're not going to do that. Then we have 3 on 1. So that's 3 times 1, which is 3. We have 1, 2, 3, 4, 5 on 2, which is 10. We have 4 on 3, which is 12. We have 3 on 4, which is 12. 1 on 5, and 1 on 6. All right, and we're going to add those up. All right, 3 and 2 is 5, plus 2 is 7, plus 5 is 12, plus 6 is 18. Carry the 1. And 4 ones there, so 48. So we're going to have to do some division. All right, we have 20 total players, as I have circled up there. So we're going to divide 20 into 48. All right, and that's going to go 2 times. So 2 times 20 is 40. Subtract and you get 8. And depending, you may want to take it out to the tens place. I always like to when you're doing a mean. So bring down that 0, and 20 goes into 80 4 times. All right, so the average number of bases here, or the mean average of bases, is 2.4 bases for those players. This has been a quick tutorial on how to read and analyze line plots and dot plots. Thank you for joining me.